according to the Bohr's theorem, the electronic energy of the hydrogen atom in the nth orbit of the Bohr model is, it is given something value. The question is the longest wavelength of the light that will be needed to remove an electron from the third Bohr orbit of the helium plus ion. So we use this formula. So this is for the hydrogen. Carefully, is hydrogen atoms. If you take the helium atom, so you have to apply it multiplied by the z square also. So energy of nth orbit will be something minus 21.76 into 10 to the power minus 19 into z by n whole square, that is joule per atom. But for the helium atoms, so what is the energy? So minus 21.76 into 10 to the power minus 19, and z for helium is how much? So z for helium is 2 square. Now for the longest wavelength means the electron is knocked out from the third orbit to infinite orbit. So it is going from third orbit to infinite orbit. So if you take the difference infinite orbit of square minus this is 3 square, then this becomes your negative value. So higher minus lower. So if you solve it, so on solving, so this becomes your 9. So this is again no value is there. Now delta, this is En is nothing but the delta E. So that is the energy. If you are taking difference, this will be delta E. Delta E is nothing but the Hc by lambda. Lambda will be a maximum. Why it is maximum? Because your electron is going from third orbit to infinite orbit. So in that case, lambda will be maximum. So this is minus 21.76 into 10 to the power minus 19 into 4 divided by 9. So lambda max will be equal to, so lambda max will be equal to, Sc we know very well, you have to multiply. So this is equal to 6.625 into 10 to the power minus 34 multiplied by 3 into 10 to the power 8 and multiplied by 9. And if you divide it, so on dividing minus 21.76, so again 10 to the power minus 19 into 4. So this is the value. So if you solve it on solving, you will get 2.055 into 10 to the power minus 7 meter. Or you can say 205.5 nanometer. So this is the value there. So this value is, so according to C, this is the positive value. And one thing is why minus is removed. So this minus will be removed because when you are taking from minus this side, so this will be value will be your positive. This minus this, so minus will be automatically removed. So finally, our answer is this. The uncertainty in the location of the circulating electron is equal to the its de Broglie wavelength. Means delta S x is equal to your de Broglie wavelength, that is h by p. What is the minimum percentage error in this measurement of the velocity? Velocity delta v by v. Under these circumstances will be approximately. So we have to find a minimum percentage error. So first already given, so delta x is equal to lambda. This is de Broglie wavelength, which is nothing equal to h by p. Now from Heisenberg principle, uncertainty principle, so Heisenberg's principle says that delta x multiplied by delta p is greater than equal to h by 4 pi. Now from here, so delta x is already nothing but the lambda. So we can h by p, so we can write here h by p into delta p, which is equal to h by 4 pi, because they are asking minimum. So minimum means you have to be equal. So delta p by p is there. So delta p by p we can write. So again, we divide by mass. So delta m into delta v by m into v. So we cancel and multiply by 100. So this becomes your h by 4 pi multiplied by 100. So this is the your minimum percent error in velocity. So if you solve it on solving, h by 4 pi, so 4 into, so h we know the value, so it becomes your this will be h by 4 pi. So this is h by p, so this is cancel out. So this is again 1 by 4 pi. So 1 by 4 pi, 1 by 3.14 into 100, and if you solve it, it becomes your 7.96, means approximately equal to your 8. So this answer is correct. Angular momentum of the electron for hydrogen atom is proportional to, so angular momentum is m into v into r, that is equal to nh by 2 pi, this value, but we have to find in terms of r. So we can write angular momentum is proportional to n, we can say like that. Now for radius. So radius we know that is proportional to, for nth orbit is proportional to r naught n Bohr radius into n square by z. So here you can put n. So since they are asking for hydrogen atom, so z is equal to 1. So we can say it is proportional to n square. So n will be proportional to square root of r. So we can substitute this value here. So angular momentum will be proportional to square root of r. So our answer will be correct. So this C option is correct. The stopping potential as a function of frequency is plotted for two different photoelectric surface A and B. The graph shows that the work function of A is. So this is the example of photoelectric effect. You can see this is the stopping potential versus frequency, and A and B are two different metals whose threshold frequency is given by drawing the slopes. So we can say the threshold frequency of A is lower than that of B. So this means that the work function of A should be lower than that of B. So greater than that of B, work function of A is greater than that of B. So this is the wrong answer. This is wrong. It is smaller than that of B. So this is correct. It is same as that of B. No, this is wrong. Such that no comparison can be done from this graph. This is absolutely wrong answer. Only B is correct answer. Aluminum fluoride will exist as a dimer, while BF3 will exist as a monomer. So BF3 exists as a monomer, while aluminum fluoride exists as a dimer. Means it will form Al2F. So it is your Al2F6, while this is BF3 only monomer. The dimer means Al2F6. Which of the following explanation is suitable for the above statement? So this is your you can say Al2F6 and BF3. This is a monomer, this is a dimer. Why is so? The smaller boron atom cannot accumulate 4 large size fluoride ions. No, this is wrong. This is not possible. The energy released by the formation of an additional bond to another boron atom is not sufficient to compensate for the loss of energy to the system in overcoming the BF, that is P pi bond, back bonding in the monomer itself. Yes, this is correct. Because whatever energy is there, that is not sufficient to just overcome this P pi bonding. So overlapping also there, but this is not overcoming. So this answer can be correct. The octet of the boron atom is complete. No, this is correct. Incorrect. This is not complete. So due to non-availability of electrons in boron atoms, no, this is also not a proper answer. So only proper answer is the second one. So this answer is correct.